1010 Data's transformational query language can control complexity by reducing the number of queries needed for a report. Complex queries or complete reports that would be challenging to express in a single SQL query can be done in a single 1010 Data query. This is due not only to the 1010 Data query language, but also the language's built-in advanced analytical functions. A single query reduces complexity and improves performance through the reuse of intermediate results. To illustrate this, let's use this query based on sales transaction data at line item granularity. We want to know, for each product, what was the percentage of sales attributed to the West Division in 2017? We first use a base tag to start with the sales transaction data. Next, we select all records where the transaction happened in 2017. The third line is a link to a store master table on the store keys. The next three lines contain will-be definitions. The SKU total column is created, containing the sum of the X sales column, grouped by SKU. The West total column is created, taking advantage of the second argument in a G function, which performs selection. The third will-be calculates the percent in West column, dividing the Western sales total by the sales total for each product. The next line is a selection. Remember, G functions do not reduce the dataset. We started with line item granularity, but want product level granularity in the result, so we select the first record for each product. Finally, we add a call word statement, so we only display columns of interest. We also want to know what percentage of each product's revenue came from the state of California. We'll just need to make a few additions to the query, shown in red. First, we add in the CA total field, which computes the sum of sales by product where the sale occurred in California. We again use the selection argument of the G function. Next, we add a percent in CA field, which divides California sales by the total sales for the product. Since we already have total sales computed, we can reuse these results. The last change includes the new percent in CA field in our displayed output. Let's answer two more questions. What percentage was from female shoppers? What percentage was from people born before 1970? We can answer these with a few simple additions to our query, highlighted in red. The first change links in a customer master table, providing attributes for each customer. All other changes compute the additional metrics using the same approach as before. The query on the left treats each answer as separate result sets that you then join. It does not use G functions or take advantage of the transformational query language. It uses substantially more query code to achieve the same result as our query, seen on the right. More code means more difficulty understanding and maintaining this query. The left version is longer and more difficult to read. It's also far less performant than our query, which leverages G functions and the transformational query language. In SQL, this analysis might be broken up into several queries, each involving a self-join. The calling application would then assemble the separate results into a report. A temporary table might be used. In 1010 Data, the entire report can and should be created in one query, reducing code complexity and improving performance.